Okay, we're going to go through solving systems of equations, three equations, three unknowns. And most of you have already gone through solving two equations, two unknowns, where you solve for an x and a y. But in this, you're actually solving three equations, three unknowns. Okay, and most of the time, like if you're looking at three equations, three unknowns, and you can think of it as the three planes that I've shown there intersecting. Okay, you can also visualize it in this room, three planes intersecting, like the front wall, the side wall, and the ceiling intersecting a point up there. And that's kind of what they're showing. This would be just the bottom part of this picture right here. Okay, or three equations, three unknowns would be like three lines intersecting in a point, but they're out in space. Okay. The other choice is you might end up with three planes intersecting in a line. And if they intersect in a line, you would have, right here, you'd have an infinite number of solutions if they intersect in a line. Here you'd only have one point. Okay, then you could also have the possibility where the planes don't intersect at all. So this is one possibility down here where the planes don't intersect. This would be another possibility, and this one where you have three parallel planes, they don't intersect at all. Down here, all three planes don't intersect. It has to be all three planes intersecting at either one point or at a line. Okay. Yep. So these, when they say no solution, these are your possibilities for your three planes. Okay. This, if you get an ordered triple, it used to be we did ordered pairs. Now we're going to do an ordered triple, and it's always alphabetical when you write your answer, but they would intersect in one point. This one would be where you would get a true statement. Like, remember last week when we got like 5 equals 5 and it's a true statement? Then you'd have to say all the points along that line would be solutions. Okay? Okay, so I'm going to take you through one example, but I'm going to work it two different ways. You actually have done this on two equations, two unknowns. We're just going to extend it to three equations, three unknowns. So we're going to do the solve it algebraically. Okay? And I'll take you through two methods. And a lot of this one is just kind of staying organized. I'm going to solve this algebraically by, you can call it the elimination method. And depending on your author, some authors call it linear combination. Oh boy. Thanks for asking that. Thanks for asking. That could have saved me 20 minutes, half hour. Okay, so here's one problem. First equation is 5x plus 3y plus 2z. And notice my z's, I put a line through them so you can tell a 2 from a z, equals 2. So it's 5x plus 3y plus 2z equals 2. Second equation is 2x plus y minus z equals 5. It's 2x plus y minus z equals 5. And then the third equation is x plus 4y plus 2z equals 16. It's x plus 4y plus 2z equals 16. And now if you have a different colored pen, what I would do is I'm going to go through, and I just to keep track of these, I number this equation 1, equation 2, and equation 3. Okay. We're going to use elimination, and you always want to look for any of them that you could eliminate easily. And if I look at this, I would probably look at the z's, the ones that I would want to eliminate. Okay, so I'm going to work with equation 1 and 2 together. And if I want to eliminate the z's, okay, I could multiply equation 2. Take that 2x plus y minus z equals 5. And if I want to eliminate And I'm going to work with, I guess I'll write them both down. So I want to work with those two, and I want to eliminate the z's. What can I multiply this top equation by on both sides? 2. I want to try to get the signs opposite so that I can add. So I'm going to multiply by 2 on both sides. Okay, so I'd have 4x plus 2y minus 2z. I'm just multiplying that out, distributing that, equals 10. The first equation stays the same, 5x plus 3y plus 2z equals 2. And now if we add, the z's are going to drop out. So we get 9x plus 5y, check my arithmetic, equals 12. Okay, and that is a new equation with just 2 unknowns, and I'm going to number that equation 4. Okay, and you need to work with 2 other equations. I could work with 1 and 3, or I could work with 2 and 3. I think I worked with 2 and 3. But you could do it the other way also. So I'm going to work with 2 and 3. So if I do my equation 2, and I'm still eliminating the, I'm still going to eliminate the z's. So what can I multiply equation 2 by? 2. So multiply this by 2. And you want either parentheses or brackets on both sides. Show what you're doing. So if I multiply this out, I would have 4x plus 2y minus 2z equals 10. Didn't we actually do that over there? Yeah, we did the same one. So we'd have x plus 4y. We could have just used that equation. Okay, and now if you add, the z's should drop out, right? So we'd have 5x plus 6y. The z's drop out, equals 26. Okay, and that's my new equation 5. Now I have equation 4 with 2 variables. Okay, I've got this equation with 2 variables, and I've got this equation with 2 variables. So put them together. Okay, so I'd have my equation 5 is 5x plus 6y equals 26. Okay, you can eliminate either one. Let's say I eliminated the x. Hang on, let me see if that's what I did. Yeah, I eliminated. Yep. Okay, so if I eliminate, I guess I eliminated the y. Let's do it the way I did on my notes. So I eliminated the y. So I would multiply this equation by, I'm going to multiply it by 6 on both sides, and multiply this equation by negative 5 on both sides. Okay, so I'd have, on the top equation, I'd have, what, 54. Check my arithmetic. I have 54x plus 30y equals 72. Then I'd have negative 25x minus 30y. And when you multiply that, you get a negative 130. Negative. Okay. And now if you add those together, the y's will drop out. Okay, and you end up with 29x equals a negative 58. Divide by 29 on both sides, and x equals negative 2. Okay, and once you get an answer, highlight it, circle it, double underline it, something. Okay, and then substitute that back into either equation 4 or 5. Okay, because that's the x and the y. So let's go back. If we did that, we'd have, let's do the 9x plus 5y equals 12. So we have 9 times a negative 2 plus 5y equals 12. So that'd be a negative 18 plus 5y equals 12. Add 18. So you get 5y equals 30. Divide by 5, and y equals 6. So we got another answer. Okay, now go back, and I would say pick probably equation 2 is the easiest. Okay, so let's go back to equation 2. So we'd have 2x plus y minus z equals 5. So 2 times a negative 2, our y was 6 minus z equals 5. So we'd have negative 4 plus 6 minus z equals 5. That'd be what? 2 minus z equals 5. We could subtract 2 on both sides and you get a negative z equals a negative 3. 3, positive 3, sorry. And I put it back into the, you can put it back into any of them, but I put it back into that one because there's 2 coefficients that are 1. Then once you get the x, you put it back into either 4 or 5 that just has an x and a y. It just has 2 variables. Then once you get 2 variables, then put it back into any of the beginning 3 equations. So our final there, z is negative 3. Okay. So now you need to write the ordered triple. Okay, the ordered triple would be the x, y, z. It's alphabetical. So the x is negative 2, the y is 6, the z is negative 3. And if you were going to do a check on this problem, it has to work in all 3 equations. Okay? It's negative 2, 6, and negative 3. So let's talk about the process a minute. We numbered the first 3 equations. I always look for a coefficient of 1 if I can do that on elimination. Pick a column and eliminate that same variable. You can work with any pair. Like I worked with 1 and 2, and then I worked with 2 and 3. I could have worked with 1 and 2 and 1 and 3. I could have done that also. You want to eliminate one variable. I eliminated the z. That gave me 2 new equations, 4 and 5. Eliminate one of the variables. Once you get an answer, put it back into one of those, and then put both answers back into the original. Okay, and all your answers should work in all 3. That's especially important on a test. Your equation or answers need to work in all 3 equations. Okay, now, same idea, solve algebraically. We're going to do the same equations, but this time substitution. Okay? So, same problem, different method. So, solve by substitution. So that's spelling. First you have to spell it right. Solve by substitution. Okay, and I'm going to number my 3 equations. Same 3, 5x plus 3y plus 2z equals 2. My equation 2 is 2x plus y minus z equals 5. And x plus 4y plus 2z equals 16. I look for a coefficient of 1. So y on this one, or z on that same one. Okay, if I take this equation and get y by itself, okay, bring that 2x over to the other side. So that makes it negative. Bring the z over to the other side. Plus z, and the 5 stays where it is. Okay, I'm trying to get y by itself in this equation. Okay, so bring the 2x over to the other side. I can show you. You need me to show you? Okay. If you're at that stage where you can do it by sight, I would do it by sight. So I'm trying to solve for this. Get y by itself. So subtract 2x. Add z. Okay, so you'd have y equals a negative 2x plus z plus 5. Make sense what I'm doing? Okay, I would put parentheses or brackets around that. Z equals that whole thing. Y equals that whole thing. Okay, y equals that. We solve for it in equation. Which equation did I use? 2. Now you have to substitute it back in to equation 1 and 3. Okay? So if we sub it into equation 1, so it's 3y. So now we're going to substitute this in for y. Sub that whole thing in, so you'd have negative 2x plus z plus 5. Okay, and I'm working with this equation, so I have 5x plus 3 times y plus 2 times z equals 2. Okay? Multiply this out. Okay, so I'd have 5x minus 6x plus 3z, check my work, plus 15 plus 2z equals 2. Combine like terms. 5x minus 6x would be negative x. 3z plus 2z, 5z, plus 15 equals 2. Get that 15 to the other side. 2 minus 15, negative 13. Okay, what equation is this? This is the new equation number. This is number 4. Because we're down to 2 variables there, right? And I subbed it into equation 1. Now I need to sub this into equation 3. Okay, so equation 3. I still have an x plus 4 times y, but I know that y is this. So I'm going to substitute it in. Negative 2x plus z plus 5 plus 2z equals 16. Okay, multiply this out. So I'd have x plus, minus 8x plus 4z plus 20 plus 2z equals 16. Combine like terms. 1x minus 8x, negative 7x, 4z plus 2z plus 6z. Bring the 20 over, equals negative 4. So this is our new equation number 5. 4 and 5 now only have 2 variables. Put them together. Actually, we could, let's look at 4 and 5. We got a negative x plus 5z equals negative 13. And negative 7x plus 6z equals negative 4. If I was strictly enforcing it, I would say solve by substitution. What would you solve for? Get the x by itself, because you want to look for that coefficient of 1. Okay, so if I got the x by itself, bring the x over to the right. So I would have 5z equals x minus 13, right? Agree with that? And bring the 13 back over. I'm trying to get x by itself. So yeah, I should have done that easier. You agree x would equal 5z plus 13? Yeah, I should have brought the 13 over to the left. Take the x over to the right. Yeah, I should have done that easier. Okay, now, x equals this. Substitute that in. This is still equation 4. This is equation 5. I solved for it in equation 4. Sub it into equation 5. So negative 7 times 5z plus 13 plus 6z. Now we're down to one equation, one unknown. So multiply this, we'd have the negative 35z, check my arithmetic, minus, is it 91? negative 91 plus 6z, negative 35z plus 6z, negative 29z, minus 91 equals a negative 4, add 91, so I get a negative 29z equals 87, okay, divide by negative 29, what's it going there, 3, and is that what we had up above for z? Yes, yes, and then it's really easy then to take that number, put it right back in here, and you'll have x. Okay, and then go back to any of the beginning 3 equations, and you'll have y. So you should still get the same answers. You get negative 2, 6, and negative 3. Okay. So 2 methods, the elimination method, but I really think it's easier if you number the first 3 equations, and then find equations 4 and 5 in both methods. Okay. Okay.